Hello again, my algebra friends. All right, so we are starting the back page of our graphing exponential functions notes. And I just want to, before I talk to you about this new vocabulary here, I just want to reiterate what I said at the very end of the last video, is that as our graph, it's going to swoop up and keep getting bigger and bigger and bigger and bigger, right? But if we go toward the negative numbers, this graph is never ever going to touch or cross the y-axis, okay? It's just going to keep getting closer and closer and closer because we're dividing by 2 every time. We went from 16 to 8 to 4 to 2 to 1, a half, a fourth, probably an eighth, a 16th, a 32nd. Like, we're going to keep getting closer and closer and closer to 0, but we're never going to get to 0, okay? So that brings up our new vocabulary word, which is a funny one. It's asymptote, okay? And when we say an asymptote, first of all, not all functions have them, all right? Linear functions don't have them. That's why you've probably never heard of it before. But when we get into fancier, more complicated graphs, we do. And it's basically a line that the graph approaches. It approaches, but never gets to. Okay, and so some graphs have horizontal asymptotes, some have vertical, and some have like diagonal asymptotes. So when we are looking at exponential functions, as you can see, this graph is going to, if we're going this direction, it's never going to get to 0, which means it will never get the x-axis. So that's going to be a horizontal line that it's going to keep going toward and never get to. All right, so exponential functions have a horizontal asymptote. Now in Algebra 1, all of the asymptotes we're going to be dealing with will be the equation y equals 0, which means the x-axis. Okay, when you get into Algebra 2, we're going to start translating and moving these functions up and down in different places, and so you're going to learn some more rules there. But this year, everything we do will never cross the x-axis. We'll never touch or cross the x-axis. So the asymptote on all exponential graphs will be at y equals 0, otherwise the x-axis, which means the curve will approach but never touch or cross the x-axis. So be careful when you're drawing it. All right, so let's do a couple more graphs here, and you may be able to do these on your own. So first of all, let's take a look. Y equals 2 times 1/2 to the x power. When we look at the b value right here, it is less than 1, which means we're dealing with decay. All right, so when we graph it, we know from left to right, our graph should be going down in an exponential fashion. Okay, so it's going to be rapidly declining and then approaching 0 going this way. So still we'll have that horizontal asymptote of the x-axis, but it's going to be swooshing down instead of swooshing up from there. All right, y-intercept. When x equals 0, what do we get? So 1/2 to the 0 power, that's going to be 1. So the y-intercept, remember that's the a value, so that's going to be 2. So we know that our graph is going to hit the y-axis at the point 0, 2. And now we can fill in the rest of our chart. And of course, always better to do it in order. I noticed some of you are like jumbling up your numbers when we were doing functions earlier. Let's put them in order so it follows that progression. All right, so let's take a look at what we really have here. So this is going to be y is going to equal 2 times 1/2 to the negative 2. Y is going to equal 2 times 1/2 to the negative 1. Y is going to equal 2 times 1/2 to the 0. We already decided that's going to be 2. All right, y is going to equal 2 times 1/2 to the 1, and y is going to equal 2 times 1/2 squared. All right, let's see what happens. So when we take 2 times negative 1, or 2 times 1/2 to the negative 2, again, the negative does not change the base. All right, but I just want to kind of remind you of something. So 1/2 to the negative 2 power means 1 to the negative 2 over 2 to the negative 2. And basically, they're going to swap places to make them happy, right? So we're going to have 2 squared over 1 squared, which is going to actually equal 4. So this is going to be like 2 times 4, which is 8. All right. Same thing. 2 times 1/2 the negative 1. 1/2 the negative 1. It's the reciprocal. It's going to be 2 times 2, which is going to be 4. And already you're probably noticing, remember we have that common ratio of 1/2. So basically we're multiplying times 1/2 every time we go down our table, which is the same thing as dividing by 2. So if you're understanding the pattern, 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is going to give us 1, divided by 2 is going to give us 1/2. All right, and you can test that out on your calculator and see if I'm right. So let's get those graphed. So we have -2, 8. And just like we said before, if we understand that we're going to keep dividing by 2, right, as we go this direction, we could add a couple more points on here if we wanted to, because if we get to 3, we're going to be at, instead of a half, we're going to be at a 4th, and then at 4, we're going to be at an 1/8. So again, we're going to keep getting closer and closer to 0, but never cross. And going this direction, we're multiplying by 2 if we're going backwards, right? So if we start, I'll just stay here. 1 times 2 is 2, times 2 is 4, times 2 is 8. Times 2 would be 16, so if I wanted to add another dot on here, I could, and then after that, I'd be up to 32. All right, so my graph this time, I'll use a different color here. All right, let's see if I can do this without, I don't necessarily draw the whole thing at once. All right, and then remember, I do not want to cross or touch, and we do our very best. All right, so there is our function. One more. And then you're going to go practice on your own. Okay, y equals 2 times 3 to the x. We have a number greater than 1 here in the b position. That is going to be growth, because b equals 3, and that means that's greater than 1. Identify the y-intercept. Again, the y-intercept is going to be the a value. So when x is 0, the y-intercept is going to be 2. Let's fill in the rest of our chart. -2, -1, 0, 1, 2. Again, please put these in order. All right, let me write out the actual math here. Y equals 2 times 3 to the -2. Y equals 2 times 3 to the -1. Y equals 2 times 3 to the 0. Y equals 2 times 3 to the 1. Y equals 2 times 3 to the 2. All right, so let's see. I'm going to start down here with my positive exponents. Okay, so 2 times 3 to the first power, that's 2 times 3, that's going to be 6. All right, 2 times 3 to the second power, 3 to the second power is 9. 9 times 2 is 18. All right, and then now I see what my pattern is. So it looks like, just looking at these three, it looks like I have times 3, or if I go the other direction, I'm dividing by 3, dividing by 3. If I take 2 and divide by 3, I'm going to get a fraction 2/3, which is not really something I wanted to graph, but hey, I'm going to have to do it. Divide by 3 again, I'm going to get 2 over 9, so I'm going to keep getting smaller and smaller and smaller as I go this way. And again, 2 times 3 to the -2, remember that's 2 over 3 squared, because we want to make the 3 happy if you're more comfortable doing it that way. All right, let's get these points on here. So I usually like to start at my intercept 0, 2, because I think that one's easy for me to graph. All right, 1, 6, 2, 18. And if I go the other direction, I'm going to have -1, 2/3. So that's going to be up here close to 1. -1, 2/9, that's a little bit less than 1/3, and then it's going to keep getting smaller from there, but never cross 0, okay? All right, so let's see if we can do this. So swoop, don't touch or cross 0, but it's almost impossible with a fat pen like this. And I do have a swoop up. Is that what I expected? It is a growth graph, and from left to right, it is going up, and so there we have it. Have a great day and enjoy your practice.